Nobody in Comanche Flats, Kansas thought much of it that first summer when 11-year-old Amos Kendrick started sitting out on the porch every evening after dinner with a stopwatch, a small notebook, and a thermometer, counting cricket chirps for exactly 14 seconds at a time and writing down both the count and the temperature before moving on to check the same measurement at 3 other spots around the family's wheat and sorghum operation. Most of Comanche Flats, on the rare occasions anyone heard about it, assumed Amos's project was simply a quiet, slightly odd kid's summer hobby, the kind of thing an 11-year-old does for a few weeks before losing interest. Nobody expected Amos to keep it up every single evening for an entire summer, and nobody expected that by August, his careful, patient counting would have built a dataset detailed enough to flag a developing drought trend across the region nearly 3 weeks before the state's own agricultural monitoring reports caught up to what his notebook had already been showing for days. If stories about quiet curiosity, patient observation, and the surprising science hiding in ordinary summer evenings matter to you, this is exactly the kind of story we tell every week. Go ahead and hit subscribe so you don't miss the next one. And if this story moves you, tap that like button before you go. It genuinely helps this small channel find the people who care about stories like Amos's. Now let's find out what those cricket chirps were really telling him, and why an entire farming community would end up grateful he never stopped counting. Comanche Flat sits in the wheat country of south-central Kansas, flat, fertile ground where the Kendrick family had farmed wheat, sorghum, and a modest cattle operation for 3 generations. Amos was the younger of 2 sons born to Grant and Delia Kendrick, a quiet, observant boy who'd always shown more interest in the small, patient details of farm life than his older brother Dean did. The particular way certain fields drained differently than others, which sections of pasture greened up first each spring, small distinctions that Amos noticed the way some children notice sports statistics or video game details, with a genuine, sustained fascination that adults around him found endearing without always taking especially seriously. The cricket project started that June, sparked by something Amos's science teacher, Mr. Halloway, had mentioned almost as an aside during the last week of school, a real, scientifically documented relationship between cricket chirp rate and air temperature, formalized over a century earlier by a physicist named Amos Dalbert. Count the number of chirps in 14 seconds, add 40, and the result gave a surprisingly accurate estimate of the temperature in Fahrenheit. Mr. Halloway had mentioned it almost in passing, an interesting bit of trivia to send the class into summer with, and most of Amos's classmates forgot about it within days. Amos didn't forget about it. He spent the first week of summer testing the relationship himself, counting chirps and comparing his estimate against the actual thermometer reading on the back porch, refining his counting technique until his estimates consistently landed within a degree or 2 of the real temperature. What started as simple curiosity about whether the science teacher's trivia actually held up in practice gradually expanded, over the following weeks, into something considerably more systematic, as Amos began wondering whether the relationship might reveal something more useful than just confirming a temperature he could already read off a thermometer sitting 6 feet away. He mentioned the idea to his father that June, the germ of a bigger project taking shape in his mind. If cricket chirp rate tracked temperature that reliably, and crickets were also known, as he'd read further on his own that week, to be sensitive to humidity and moisture conditions in ways that affected both their chirping behavior and their overall population density in a given area, then tracking chirp counts consistently over an entire summer, across multiple fixed locations on the property, might reveal patterns about the season's developing heat and dryness, considerably earlier than waiting for visible crop stress or official weather reports to catch up. Grant, a practical man who'd farmed the same ground his whole life and had genuine respect for careful observation even when he didn't fully follow the science behind it, told his son he was welcome to try, so long as the project didn't interfere with his regular chores. Amos took that permission and ran with it, establishing 4 fixed measurement points around the property that first week of June, 1 near the house, 1 at the edge of the wheat field, 1 near the cattle pond, and 1 along the property's western fence line bordering a neighbor's sorghum field, and beginning a nightly routine of counting chirps and recording temperature at each location, every single evening, rain or shine. His brother Dean, 16 and considerably more interested in his truck and his friends than his younger brother's summer project, found the whole thing mildly ridiculous. "You're out there every night listening to bugs," Dean said more than once that June, the kind of gentle teasing older siblings bring to a younger brother's earnest hobbies. Amos didn't argue the point much, simply continuing his rounds each evening with the same quiet consistency regardless of what Dean thought about it. Word of Amos's project moved through Comanche Flats the way most small, odd habits did in a farming community that size, through the co-op, through casual conversation among neighbors who'd known the Kendrick family for years. Hollis Detmer, who farmed the section adjoining the Kendricks' western fence line, mentioned to another farmer at the co-op that the Kendrick boy had taken to counting cricket chirps every evening like it was some kind of job, a comment delivered with genuine amusement rather than any real unkindness, the settled assumption among most of Comanche Flats being that Amos's project was a charming, if slightly eccentric, way for a thoughtful kid to spend a long summer, interesting to him personally, but not something carrying any real practical weight for the rest of the community. Amos kept at it anyway, his notebook filling steadily through June and into July with 4 nightly readings, temperature, chirp count, and rough notes on humidity and recent rainfall, cross-referenced against a simple calendar he kept alongside his measurements. By midsummer, he'd built something considerably more rigorous than a passing hobby, a genuinely consistent dataset spanning 6 full weeks, detailed enough to reveal patterns that day-to-day observation alone rarely made visible. What that data began showing, gradually through July and then with increasing clarity into early August, was a trend that concerned Amos more than he initially knew how to articulate to anyone else. Chirp counts at all 4 locations were climbing steadily, consistent with rising temperatures that matched the season's general heat, but the rate of increase, when Amos plotted it against his notes on rainfall, which had grown increasingly sparse through July, suggested something beyond ordinary seasonal warming. Crickets, sensitive to moisture stress in ways that affected both their calling behavior and their overall activity levels, were, according to Amos's careful tracking, showing a pattern of accelerating dryness stress considerably earlier in the season than his father's own casual assessment of the field suggested any real concern. Amos brought his notebook to his father that first week of August, walking Grant through 6 weeks of consistent data with the kind of careful, methodical explanation that surprised Grant more than he expected from an 11-year-old's summer project. The chirp rate trend, Amos explained, when adjusted for the temperature relationship Mr. Halloway had originally described, suggested the crickets were responding to moisture stress considerably beyond what that summer's rainfall totals alone would predict, a pattern Amos worried might indicate developing drought conditions building faster than the general regional weather reports, still describing the summer as merely dry rather than genuinely concerning, had yet caught up to. Grant, who trusted his son's careful work more than he might have trusted a stranger's unfamiliar claim, took the concern seriously enough to call the county extension office that same week, describing Amos's observations and asking whether any early drought indicators had shown up in the office's own monitoring data. The extension agent, a measured woman named Priscilla Okonkwo, admitted that preliminary soil moisture readings from the broader region had, in fact, begun showing a concerning downward trend in just the past several days, data that hadn't yet been compiled into any formal public drought advisory but that matched, disturbingly closely, the timeline Amos's own notebook had already been tracking for nearly 2 weeks. Grant didn't wait for the formal advisory. He adjusted the farm's irrigation schedule immediately, prioritizing water for the wheat crop's most vulnerable growth stage rather than spreading it evenly across the property the way he'd originally planned that season, and began making early arrangements for supplemental cattle feed given the increasingly likely prospect of reduced pasture growth through the rest of the summer. The formal state drought advisory came out nearly 3 weeks later, confirming what Amos's data had already suggested well before any official monitoring caught up, a genuine, developing regional drought that would, by the time it was fully recognized, cause significant losses for growers across the broader area who hadn't adjusted their water and feed planning early. Hollis Detmer, whose own sorghum crop suffered considerably worse that season from the delayed adjustment most growers made only once the formal advisory hit, came by the Kendrick property that September, considerably more serious than the amused comment he'd made at the co-op that June. "Grant tells me your boys' bug counting caught this drought 3 weeks before the state did," he said. Grant didn't disagree and explained, as best he could, the careful logic behind his son's project, chirp rate, temperature, moisture sensitivity, a chain of reasoning that had started with a science teacher's passing trivia and ended up genuinely useful to an entire farming community. By the following summer, Priscilla Okonkwo had reached out to Amos directly, inviting him to present his methodology at a regional agricultural extension workshop that winter, and had begun incorporating informal cricket-based moisture indicators, cross-referenced against the county's own formal soil monitoring, into the office's broader early warning outreach for the following growing season. Amos never made much of what happened that August. When people asked how he'd known a drought was developing before the official reports caught up, he usually gave some version of the same simple answer. He hadn't known anything about drought forecasting when he started. He just wanted to see if his science teacher's trivia about crickets and temperature actually held up, and once he started counting seriously enough to notice something changing, he couldn't quite stop paying attention to what the numbers were telling him. There is a particular kind of insight that only comes from sustained, patient counting, the kind no single evening of listening could ever reveal on its own. Amos Kendrick hadn't set out to warn an entire farming community about a developing drought. He'd simply wanted to test whether a piece of science trivia was actually true, and in testing it thoroughly enough night after night all summer long, he built something that mattered considerably more than confirming a temperature he could have read off a thermometer the whole time.